This is question 65 on chemistry from the 2011 IMAT. So we're asked which one of these reactions below is not an acid-base reaction. So we have nitric acid and perchloric acid forming this positive species and the perchlorate ion. We have two ammonias forming the amide and the ammonium ions. Then we have this aluminium hexaaqua 3+, add water, forming this hydroxide species and the hydronium ion. Then we have methane and this antimony species forming CH5+ and this negatively charged ion. Then we have iron trichloride and 6 waters forming the hexaaqua ion and 3 chlorides. So firstly, what is an acid-base reaction? This is, at least in the Bronsted-Lowry sense, this reaction between some generic acid HA and a generic base B, forming A- and BH+. So what's happened is the movement of a proton or a hydrogen ion H+ from the acid to the base. So we just need to check if this is happening in each of these reactions. So firstly, we have nitric acid and this perchloric acid. So you might initially think two acids, there surely can't be an acid-base reaction, but you can see that one of the H+ has moved from the perchloric acid to the nitric acid. So the nitric acid has actually acted as the base here to form the BH+, and the perchloric acid has acted as the acid. So this is indeed an acid-base reaction. Then we have the two ammonias, which again, confusingly, you wouldn't think is an acid-base reaction, because we usually think of ammonia as a base, but you can see that one of them has been deprotonated by the other. So this one was the acid and this one was the base. So we've moved a proton from one species to another. So this again is an acid-base reaction. Next, we've got this aluminium hexaaqua reacting with water. So is this an acid-base reaction? You can see that we formed the hydronium or H3O+ ion. So the water must have taken an H+ from somewhere, and it's in fact deprotonated one of the aluminium's waters. So you can see that water acted as a base and taken a proton away from the aluminium species. So again, we have an acid-base reaction here. So next, we've got methane reacting with this antimony species. Is this an acid-base reaction? Well, you think that methane surely can't act as an acid or a base, but in fact, this thing is called the superacid, which can protonate pretty much anything. And you can see that methane has picked up a proton to form CH5+, and where's that proton come from? It's been given up by this antimony species. So methane is acted as the base here, and this was the acid. So yes, this is an acid-base reaction. Then we have iron trichloride and water, and all that's happening is the ligands are swapping. So we're kicking out these chlorides and sticking waters in their place. So is this an acid-base reaction? Well, no, because we've not actually moved any hydrogen ions around, we've just swapped the ligands from the iron. So this is not an acid-base reaction. So our final answer is E is not an acid-base reaction. So the answer is E.